All right. So we're going to be doing exactly what we did on Tuesday. Ooh, that's not what I meant. That one, that's what I meant. Where we're taking this left-hand side, the side that has our x squared and our x, and we're going to see if this is a perfect square, if that's the perfect square trinomial. We always know that x squared is a perfect square. 9, that one's a perfect square. And our way to double check is to make sure that this middle piece is 2 times the front one times the back one. And it is. 2 times x times 3 would give us 6x. So to put this in our perfect square form, still going to equal 16 on this side. We have our front term, we have our back term, and it's always going to use this operation. So it's going to be x plus 3 squared equals 16. That should hopefully be vaguely familiar from Tuesday. So now solving with the square roots, what do we do as our next step when we're solving with the square roots? Square root both sides. Exactly right. Ooh, that's not the color I wanted. So we're going to square root both sides. Whenever I square root both sides, I'm going to use a plus minus. So we're going to wind up with x plus 3 equals plus or minus the square root of 16, which is 4. So then I'm going to split this into our two options for our solutions. We're going to have x plus 3 equals 4 and x plus 3 equals negative 4. Then we got to finish solving for x. What do we need to do to get x by itself? Subtract the 3. And we get that x equals 1. And again, we're going to subtract 3. And we get that x equals negative 7. Questions on that first one? Because it's been a couple of days since we did that. So we're going to need it again today. I only have another one to practice with. The second one is very same vibe. Solving with the square roots. We're looking at just this left-hand side. Our front term, that's an x that's been squared. Our back term, what squared gives us 25? 5. And our middle term is 2 times one of each of those, x times 5. And it is. So we can put this into our perfect square form. And I know I'm right at the bottom of the screen. We're going to have our x. We're going to have our 5. It all equals 11. And we use this operation here, so it's going to be x minus 5 squared. And then just like we did on the last one, we're going to go ahead and square root both sides, giving us that x minus 5 equals plus or minus. Is the square root of 11 something we know? No. So we're going to leave it as square root of 11. Then we're going to look at this piece. We're still going to get x by itself, so we're going to go ahead and add 5 to both sides to get x equals 5 plus or minus square root of 11. And that's how we're going to leave it. If you want to split it into your two cases and do 5 plus square root of 11, 5 minus square root of 11, that's fine. If you want to type those into your calculator and get to decimals, that's fine too. Right now, I'm not asking you for that. We will eventually do that, but we're not going to right now. Questions on these two? Okay, because we're going to be working with these perfect squares again. They're hanging out for a little while. So what we're going to do is we're going to say, well, what if I don't tell you it's a square root property and it's not perfectly square on one side? Is there a way we can make it be that way? And there is. So I'm going to put up the screen. It's going to have a giant wall of text on it, just as a warning. Okay? Because this is a screenshot from your book. And what we're going to be doing is we're going to be doing something called completing the square. And it's a whole lot of gobbledygook on here. What we're looking at is we're going to take a perfect square trinomial like this. And we're going to be calculating what number has to go here, what number is going to have to be the c in order to make it be our perfect square trinomial. Plus something, that's a question mark, squared. You do not need to try and write down this whole page. So we're going to be using that kind of check we used on the middle term to help us figure out what piece needs to be at the end. And I promise there's a reason we're doing this, but it's one of those things we got to do it for a little while before we start to see the reason. Okay, so what we're going to be doing to find what term is supposed to be here at the end is we're going to take our middle variable, that's our b. We're going to take our b and divide it in half. Whatever that piece is gets squared and added on to the end. Which I know it's a whole lot of gobbledygook when it only has letters. Completing the square is, I think, one of the most difficult concepts to wrap our brain around. So if this is hard, that's normal. So I'm just going to skip past this wall of text. So what we're going to have is we're going to say, okay, what number needs to be c in order to make these perfect squares so that I could put them in that x plus something squared form? Just like we did in the bell work, we have this being x squared. And we want to find out what c is. The thing is, the only thing I know about c is that whatever this guy is, that's squared, we should have 2 times x times whatever the heck that is. Right? Can I see that part? So 2 times x times something gives us 10x. What's that something going to be? 5. So question mark is going to be 5. If question mark is 5, what's c? 25. Because it's whatever this piece was squared. So if c is 25, we can write this as x plus 5 squared. Yes, sir.
Where do we get 2 from?
That's in the, let me zoom it in so we can actually see what I'm pointing at. when we would look at our middle term? This guy. So the 2 and the x, so the x is always our front term. The 2 is because it's the middle, and it's always this guy at the end. Good question. Boop. We're going to do the same thing on this second one over here. I know that my front term is going to be an x. C is something squared. And my middle term should be made of 2 times my x in the front times that something. So 2 times x times what gives us negative 8? 4. So my question mark equals 4. If you want to use a different variable, you can. I'm doing question mark because if I start throwing too many letters, it gets confusing. So if question mark is 4, what is C? 16. If C is 16, we can write this as x minus 4 squared. Okay, so it's kind of awkward, and right here we're just kind of doing half of it because we're not solving with it yet. We're going to do that on the next one, but we had to figure out how to build that C piece first. Questions on these two as they stand right now? Because what we're going to do is we're going to take things like this and use them to solve, so they're going to have an equal sign on both sides. And this is going to be solving with completing the square. So we're going to have an equation like this, and it'll say solve by completing the square or by vertex form. What that means we're going to do is I'm going to actually scoot the 4 to the other side and ignore it for a hot minute. So I'm going to take my x squared plus 18x. I'm going to leave a gap. That's going to equal, if I add 4 to both sides, 4 on this side. Right? Can you see that? Same thing, just in a different order.
Why are we leaving a gap?
Because I'm going to use the completing the square, the thing we just did. I just haven't showed you why. So I'm just leaving this gap. Because what I want to do is I'm going to do what we did on the previous screen. I want to know what this guy is. I want to find C to make this be a perfect square. So I am ignoring the 4 for a hot minute. So just like we did on the other side, what number would need to be here to make this guy be a perfect square? So if we have this one be x squared, question mark here, not 3, but we're in the right track. You just, I think, did it twice. Yeah, 9, because this is 2 times x times question mark, right? So question mark is 9, which means at the end is what? What's C? It's 81. But now we're into an equation. This is an equation. Can I just willy-nilly add 81 on the left-hand side of my equation? Are we allowed to do that? So if I want to add 81 to the left-hand side, what do I need to do to the right? I was going to say, if I add it on one side, I'm going to add it on the other, because we've got to keep it balanced. So I'm going to add 81 over here. The reason we're doing that is because now this left-hand side is a perfect square. And I can rewrite this as x plus 9 squared equals 4 plus 81 gives me 85. So we've kind of forced it to enter this point of view so that we can solve with square roots. There's other reasons we'll want this form because this is really, really close to our vertex form. We have to do a little bit of solving to get there, and we'll talk about that tomorrow. But here we're going to be solving with this. So to finish solving with this, what's our next step here? Square root both sides. So we're going to wind up with x plus 9 equals plus or minus square root of 85. Is square root of 85 one we know off the top of our head? Nope, so we're going to leave it right there for now. We got to get x by itself. Subtract 9. X equals negative 9 plus or minus square root of 85. And you can always check into your calculator to see if square root of 85 simplifies. Type it in the yellow calculator. It does not. So that is a full and complete, fully simplified answer. We'll work with getting them into decimals, I think, next week and practicing with that. But that is our full and complete answer. It's actually less work than doing it other ways, as long as we remember how to find our question mark and find C. Question mark's not a math term, it's just what I did to make it easier. We're going to try this again, because I know it's weird, a little tricksy to get used to, but I want us to do it again. So very similar vibe. I want to make this be a perfect square. So the first thing I'm going to do is I'm going to boot the 82 to the other side. I want just my x's together on the left-hand side. I'm going to have my, that's not a pen, my x squared, my minus 6x, and I'm going to leave myself a space so that we can put that c value there. And we have 9, and I'm going to add 82 to the other side. So 9 plus 82 is 91. Plus 82. Plus 82. So whenever we're completing the square, I want to get all the constant numbers over to the other side and ignore them. Because what we're looking for is what number needs to go here in order to make it be a perfect square. We know we can write the x squared, that's our front term. We're trying to figure out what number needs to be here, squared. And the way we find that is we look at that middle term where it's 2 times x times question mark. 2 times x times what gives us 6x? 3. So question mark is 3. I'm totally meant to draw a question mark there. Which means what's our c value? 9. But I can't just willy-nilly add 9 to one side of an equation. That means I also have to add 9 to the other side. The reason we want to do that is because now I know my left-hand side is that perfect square trinomial. We can solve it with square roots like we did in the bell work. So I can put this as my x in the front. It's always going to be question mark that goes in the back, so that's kind of cool. And it's going to use this sign, -3. Equals 91 plus 9 gives me 100. Questions on this part, because this is the weird part. These 3 steps. The weird part. Yes, sir.
Where'd you get that 9 from? Plus 9.
This one?
Yeah.
Since I added 9 on this side, I can't just add it to one side of my equation. It makes me unbalanced. So I've got to add it to both sides to keep my equation balanced. So since we chose to add 9 here to make it be our perfect square, I have to also add it to the other side of the equal sign. Good question. Thanks, Eric. Okay, so now we're ready to solve this. This is when we're going to come in here and square root both sides to get that x minus 3 equals plus or minus, what is the square root of 100? 10. That one we know off the top of our head, so we're going to simplify it right then and there. If you don't spot the simplification right away, it's okay to leave it as radicals until we get to the end. Since that is an integer, it's a whole number, I'm going to split this apart and we're going to get all the way down to answers. So I'm going to bring this up over here, just so it's not at the bottom of the screen. So I'm going to have my x minus 3 equals 10. And we're going to have that x minus 3 equals negative 10. That is right on the edge of the screen. That's a 10. For both of these, what operation are we going to do to get x by itself? Addition. We're going to add 3. So we're going to have x equals, add 3 to both sides, we get 13. And on my purple one, we get x equals, add 3 to negative 10, negative 7. And that's how we're going to solve those. So if it says solve with square roots or solve with completing the square, this is what they intend for you to do. And this one we could have solved with factoring. Whenever we wind up with whole numbers at the end, it is probably factorable. But we'd have to set it equal to 0, and the 2 numbers we'd wind up with are 7 and 13 that multiplied be whatever it is, and that's not one that I know off the top of my head. But this way I don't have to know what 7 times 13 is. So there are times when it does make things simpler. And what we're going to do is I'm going to pass out homework 3-5, which is today and tomorrow. You can actually do everything on it. I'm just going to show you a different way to look at something tomorrow. Okay, so you can actually do everything on this homework today. So this is homework 3-5. The first 3 are like the bell work. They're what we did on Tuesday. And then 4, 5, and 6 are where we're just finding the C value. On the back, 7, 8, 9 are what we just did, solving with the completing of the square. And then the bottom one's kind of review of bullet stuff. So we will work on this tomorrow as well. But now is an excellent time for you guys to get started, work through some stuff, and practice this a little bit. We have about 10 minutes until announcements start.